Okay, so today we're going to talk about solving differential equations, which is using the whole idea of separable equations. So remember, there are multiple ways of solving differential equations. The simplest way is by separable equations. So just a quick description of separable equations. The name basically tells you what the goal is. So what we're going to say is that when solving a differential equation, using separable equations, we will separate like variables on each, or we could say to each side of the equation. And then once we do that, once we separate everything to each side of the equation, then we will integrate each side with respect to those variables. And then once we do that, that will pretty much give us the solution that we want. So let's just look at a couple of quick examples and then we'll be done with this. So the first example would be solve the differential equation dy dx equals to x squared over y squared. So what you notice is what I want to do now is I want to separate the variables. And what's nice is I could put the y's on one side and x's on the other. So if I multiply both sides by y squared and multiply both sides by dx, so what I'm going to do is I'm going to multiply y squared. So what is that going to give me? Y squared dy dx equals to x squared. And then multiply dx to both sides, which then that gives me y squared dy equals to x squared dx. And we're always assuming that we're solving for y, right? I mean, that's kind of like what we've always done. And if you look at this, you could tell this is saying dy dx, so y depends on x. So we're solving for y. So then, once I separate the equation, so the variables have been separated on each side, now I just integrate each side. And if I integrate this side, I get 1/3 y cubed. So I'm integrating with respect to y equals to, this becomes 1/3 x cubed plus c. And then just put the plus c on one side, because if I put a plus c on this side and plus c on that side, or we would have two different constants. Eventually, when I'm solving for y, I would subtract the constant over, which would give me one constant. So you could just put the plus c on one side. Now we could solve for y. So multiply both sides by 3, which gives us x cubed plus, and 3 times c is still a constant, so we could leave it as a c, and then we can cube root both sides, and we just found our solution. So the solution to this differential equation right here, ignore the y squareds, which is this guy, ends up being just y equals the cube root of x cubed plus c. Okay, so that's basically one example. So let's look at one more example, and then that'll basically wrap up this section. Like I said, separable equations are the simplest ways we could find solutions of differential equations, but that's the only one that we're going to deal with in this class. So if I said solve the differential equation dy dx equals to 6x squared over 2y plus cosine of y. What we'll get here is that we'll once again separate variables, so that gives me 2y plus cosine of y dy equals to 6x squared dx. And once I separate, now I could integrate each side again. And what does that give me? Y squared plus sine y equals to 2x cubed plus c. Okay, now what you notice here is that unfortunately I can't solve for y here. So the solution to this differential equation is this right here, and we could stop there. Okay, so just keep in mind that there will be times, ideally we want to solve for y because it just simplifies things for us, but in this case we can't go any further, so we'll leave it at that. Okay, so remember, once you, I mean, this is the solution after all. If I were to find the derivative of this, I would get that. Okay, but what's going to happen is unfortunately I can't isolate y by itself, so I'm just going to leave it of this form. Okay, so this is still the solution of that, except it would be much cleaner if we could somehow solve for y, but in this case we would kind of be stuck with this. Okay, so that's basically what separable equations is all about. Nothing too intense going on here. Just remember, this is one way of solving differential equations.